Hello, everyone. It's Floyd again here at Enginears. I'm really pleased to say today we're joined by Rosaria Silipo, Head of Data Science at Knime. For those of you who don't know, Knime are a free-to-use, open-source, low-code data platform that makes understanding data and analytic workflows accessible to everyone. Today, we're going to be talking about a range of topics, including what is low-code, some of the common misconceptions, model training, and the importance of MLOps and the use of large language models. Firstly, Rosaria, thank you very much for joining Engineers today. It's a real privilege to welcome you to the podcast and to share with our community more about you, Knime, and the exciting journey that you're all on as well. So
Thank you for
let's kick
inviting me.
things off firstly with an no, you're welcome. And let's kick things off firstly with an introduction to you. Give us a brief overview, your background, where you are today, and your remit within the business as well.
Okay, so I'm Rosaria Silipo. I work with Knime. I am the head of the evangelist group here at Knime, of the data science evangelist group. I have worked in this field of data science since forever, so since the early 90s. My my master thesis was about neural networks at that time in the early 90s, so you can imagine how long I've been around. I moved, I did some work in artificial intelligence. At that time was already called artificial intelligence for a while. Then there was a bit of a freeze for the artificial intelligence field. And then it came back in the year 2000s or something. So since then I've worked as a consultant. I've worked for companies. I've worked for speech recognition companies. I've worked for credit card transaction companies. So a lot of experience. And then at the end, I ended up at Knime, and I, let's say, use my experience to teach the younger people and to make use cases so that everybody could use them.
Good, makes sense. And so, talk to us about your role today with Nime in the sense of the team that you're leading and exactly what you're responsible for.
So, what an evangelist does, and nobody knows what an evangelist is. I mean, my mom is happy about the title, but yeah. So what we do basically, we teach. We are a bit in between technical um, expertise, teaching, and marketing. So we tell everybody how fantastic it is to work with data science, the great results that they can achieve, and especially if they use a low code approach like Knime has. I say that it's at the cross of these three disciplines because, of course, there is a lot of teaching, not only the traditional teaching, so in courses and videos and things like that, but also, like challenges, hackathons, and more like gamification kind of teaching. So this is a bit the part that is the hardcore teaching. But then we write books, we write blog posts, we write posts on social media. So all these smaller, less traditional ways of teaching, they are a bit like more marketing, because we want to also promote how much faster it is to use low code to implement a data science solution. And then sometimes to advertise this kind of successful solutions, we need to implement the technical solution. And to implement the technical solutions, then of course we need to get our hands dirty and provide a solution, a fully functioning solution that can be used by end users, customers, or any kind of end users. Yeah, so this is a
That's a
bit.
good overview. So you're still getting your hands dirty, or not so much these days?
Uh, Me, not so much anymore. Yeah, I mean, I do sometimes when from time to time we have these retreats where we are supposed to do what we like. And yeah, then yes, then I find a use case or find a problem and I try to solve it, and then it's fun. But yeah, a lot of times I teach and I tell younger people what they could do. Yeah, my role now at the moment is more like an inspirational role. So what people could
That's really
do.
interesting. Yeah, it's really interesting how because of course, your background is very much technical and even with Nime,
Yeah.
right? So it's kind of progressed it's certainly not a role within businesses that you see very often, but I think it's I imagine it's quite powerful internally to have the knowledge and resource that you have, and to be able to deploy that as you do as well.
Yeah, sometimes I think my role is really to inspire people. Especially if you are very young in the field, you don't know how powerful it can be, and sometimes people they get a bit they don't dare to dream too much, and then sometimes my role is just to push them a bit and see, yeah, it's possible. Of course, or we find a solution that it's easier or faster or something like that, and then at the end it's fantastic when they see that it's actually the whole thing came together and it's a nice solution. It's fantastic to see how happy, how satisfied they are with the whole project. So yeah, I think that's a bit my role now. I'm an enabler. I tell
An
younger
enabler, that's a
people,
good one.
yeah, how far they can dream, and the shortcuts they can take, for best practices in the implementation of the solutions.
Sure.
That's a bit, yeah, what I do. I also, yeah, I don't know. It's a bit of I also teach them how to write. It's not only the technical part. I also teach them how to write the soft skills. How
Okay,
to tell
fine.
people.
So it's a bit of everything.
Yeah, it is. Often it's underestimated how much soft skills you need to progress in this field. Because even if you have the perfect solution, but you are not able to explain it, or you are not able also to create an interface that allows the final user to use it easily, smoothly, then it's useless, right? It can be the most perfect solution, but then nobody will use it, and then it will die. Yeah.
Yeah, for sure. It's absolutely, I completely agree. I think it's probably an underrated thing
Yeah.
that not many people talk about. Now, for listeners who don't know about Knime, I think it would be really good to give some more context around the backstory of the business, exactly what Knime is, and what it is that you're offering your user base as well. So I think you're probably the perfect person to go through this. But give us the story of Knime, and what it is that you do.
Yeah, so as an evangelist, we don't deal with money. So I'll tell you my point of view. So my point of view, Nine produces two products. One is the Nine Analytics platform. Nine Analytics platform is free. It's open source. It's low code, and it covers all your need for data science. So I usually say that's the intelligent product in the sense that it contains all the algorithms and all the data operations that you need to bring your data from A to B. And then there is another product. This is the business hub, the Nine business hub. And this one basically gives you the infrastructure, the IT infrastructure to smoothly productionize the solution that you have created with the free part. It's a different audience. Sorry. It's a different audience. So the open source product is used by everybody, and everybody can create an AI solution, for example. The business hub
Okay.
is mainly for the companies. So if you need to really productionize your solution for everybody to use without ever touching what's inside, then in this case, it's more like a company kind of business. And then in this case, it's a non-open source, it's not free, you need a license. Yeah, so it's a slightly different business, but they serve the two different purposes. One creates the solution using data operations, ETL, AI, machine learning. So all the algorithms and techniques that are used to process data. And the other one enables the productionization of the solution that you have created. So even if you have a model, you have trained the best model ever, then you deploy it, you build an application that allows the end user to use it, and then you productionize this deployment workflow. And then you can, in the Nine Business Hub, it's easy to make it available for everybody to use, for example, as a data app, as a web page, as a I don't know, a REST service, as a, yeah, whatever you want to make it available as. So
Okay.
this is
That's
how,
so it's really powerful in helping to automate, right?
yeah.
Automate that process
Yeah,
of.
yeah.
Okay.
So those are
Uh,
the two products by Nime. We are definitely committed to the open source part. We have always been open source. So this, I don't know, we believe that it's not only that we want to make things free for everybody, but we want our solution to be open to all different data sources out there. I know that everybody thinks that AI is about the algorithms, but often AI is about how much data you can ingest from different data sources. So you have now many data sources, and the problem is how to collect this data, keep it clean regularly, build a history. And that's the part that then is going to feed the machine learning algorithm. Yeah, so this part we've always wanted to keep it open source. We wanted to keep it open, so as a way to connect to different data sources, and also to connect, to integrate with different tools like Python or R. I mean, we use the low code, but if the low code is somehow our solution is not enough, you can always integrate with Python and with R.
Okay.
Yeah, what else can I say? We also decided to go for the low code. That's a decision that we took long time ago. Uh, it's a choice. I mean, some people like to code. Some people don't like or don't have the time to keep up with the coding knowledge. So we decided to use the low code for all those professionals that they have another profession and they only analyze the data on the side. So like doctors or pharma people or I don't know, finance people. So they know how to analyze data, but they don't always have the time to keep up with the programming. Yeah.
Okay. I was going to ask you in terms of kind of where you see Knime being most successfully deployed in terms of customer base and so on. Is it exactly what you just explained? Maybe less, let's call them kind of tech first folk that maybe need the platform to help kind of automate and understand certain data, but maybe don't have the power internally to be able to do that manually?
So I mean, Knime is used in a lot of things. So it's a horizontal tool. So it's used in finance, it's used in healthcare, it's used in pharma, manufacturing. So a lot of things. There are two kinds too. There are many kinds of users. There are the users, let's say, let's group them in two categories just to be very coarse here. So one category is what we have said before, like, professionals, they don't know how to program or they don't want to keep up with the latest knowledge in programming. And then they use Knime as an alternative, basically to Python or to R or to other programming tools, scripting tools. So this is one type, but there are also the programmers. So a lot of Python developers, they also use Knime. There are many reasons why they use Knime. So one, for example, is that they have a script, but if you pass the script to somebody who can program, they are never going to use it, right? Or they use it as long as it works. They believe blindly in what the script produces, and then they use it. But of course, it's a bit of a blind trust exercise in whatever the script produces if you cannot go through it and see that it has produced the things that you wanted to. So sometimes they give the script as they build it as a node inside a Knime workflow. Since Knime is low code, basically you build a pipeline of these blocks. Each block has a dedicated task, and we call them nodes. So that's why, and a pipeline of nodes is a workflow. The workflow implements your application. I just make this parenthesis because I talk about nodes and workflows, and maybe people don't know what I mean. So some Python developers, they put their code inside a node, and then the node gets imported as a normal node, as any other node, inside the workflow, and then people can still feed the right data or produce or process the output of this Python script in the way they want, so that they obtain the data in the format they want. So this is one way that the Python developers use Knime. Another way is that actually it's
Okay.
faster. So if you want to produce an application, and sometimes you need to put together the code, and if it's an easy code, you do copy and paste from the web, and maybe it works, and then it takes longer. So sometimes they just use Knime. It's faster. They train the model, they have it ready, and so even if they are Python programmers, they use Knime for the things that Knime can do, and then they only reach out to Python for special extensions that Knime doesn't have. So there are a bunch of Python
Okay.
users that actually use Knime. A third group of Python users that use Knime is that they develop nodes for Knime. So Knime, the nodes can be developed by the community. They used to be developed in
Okay.
Java, but now we have added an extension, I think 1 year ago. We have added an extension so that they can develop their own node for the community to use in Python. So this is another category
Okay.
of Python users. So we have a hardcore group of Python users also among the Knime users. Yeah.
That's a really good overview. Appreciate that, and it sounds super versatile as well, which I think is quite unique. Now, I'm interested to cover the topic of low code because I know when we first met, it was a topic that we discussed and what it actually means. So maybe for our viewers or listeners that don't know exactly what low code is, talk to me about that, what it means for businesses like Knime and exactly how it works.
Yeah, so I gave already a quick presentation, a quick summary before. So low code is, are all those pipeline, those applications that allow you to put together an application by drag and drop. Basically, you have the blocks. They each block implement a specific function. You just drag and drop it, and then function after function, block after block, node after node, then you build the whole application. So this is how low code works. It's a I mean, it's not that we have invented it. So it's something that a lot of other tools use, and frankly, it's spreading because it's easier. It's easier also for people not only who don't know how to code, but it's easier to put together. And blocks are, they're a bit coarser than instructions sometimes, and yeah, and then you have the whole thing already prepared. The 3, 4 blocks are the same as a long script in whatever scripting tool you want to use. So it makes life a bit easier, faster, more than easier and faster. And so why not? So this is a bit
Sure. And
the philosophy. Yeah, so that's how Knime works. Of course, Knime also has a core, which are the basic functions. It's actually very powerful. So there is a core that contains the basic functions around the data, the basic algorithms. But then, of course, the community provides more and more extensions. So we provide the code, we provide the framework,
okay.
but then the community adds the image processing extension, the text processing extension, the geolocation extension. So there are a number of um, institutions, research institute, universities, single contributors, companies. They all contribute with some kind of an extension to extend the usage of Knime.
Sure, and it's becoming more and more complex and more powerful as time goes on, right? With the open source for sure. And I think another topic I was interested by is a lot of people I think perceive low code as I think you described it before as kind of toy tools, right? With a misconception that it can only perform basic tasks. So talk to us about your perception here. How complex can low code be? And maybe you can share some insights as to examples of kind of more basic performance or applications versus actually some of the more complex and kind of difficult tasks.
Okay. So, I mean, I've been working in this field, as I said, for a very, very long time. So I have plenty of use cases from before Knime, but then I imported them into Knime. So I re-elaborated the same use cases that I solved using programming into Knime. So I started the first ever use case I worked on is a churn prediction. Everybody starts with a churn prediction, and every company needs a churn prediction tool. Everybody, because you always want to know if your customers, if your faithful customers are going to churn. Yeah, that's you have to. So the churn prediction is a very easy now. By now, very easy. At that time was kind of innovative, but it's very easy. It's a very easy application. You take the data, you have a bunch of customers, some churn, some didn't, based on this data set, this training set that of mixed customers who somebody churned, somebody didn't. You train an algorithm, and this model will learn based on which input features some customers will churn, have a high probability to churn, and which customers don't. So it's relatively easy. This one actually, there is an old video that on YouTube that where I promised that I would assemble together this churn prediction solution in less than 20 minutes, and so you can check it. It's very old, so it's from Knime, I think 2.7. So now we are at Knime 5.1. So you can imagine how many versions ago.
Okay, yeah.
So this was the first one.
Maybe we'll link that in the comments. I think maybe we
It's on
can share a
YouTube.
link with
You
everyone
can
to
search
check it
churn
out, get
prediction
some
with
views.
Knime. I
Yeah.
don't know. I want to take it out because it's old by now, right? It's the old version. It's the old Knime. It's old, but I don't know. It's kind of vintage. So everybody looks. That's
Nostalgic.
It has many views, so I leave it there. It's the only one that survives the old
Leave it.
version. So this is the easy solutions. I mean, they're still powerful because you can still predict which customers will churn and which not, but it's a relatively easy implementation. I mean, after that, I worked on predictive maintenance, for example, and here things became a bit more complicated because, when there are some of these manufacturing companies, they have very expensive and very um, critical machines. So these machines, they have been so expensive that you want them to work as much as possible because you have to somehow, justify the money you have spent. On the other side, you don't want them to break because they are critical piece of machinery, and if they break, everything breaks. And so you want to be careful, that they work as much as possible, but they don't break. So what used to be done is you after some time you retire the machine, and yeah, even if there was some time left, some lifetime left for the machine, well, what can we do? So this was what happened. Now, in the latest predictive maintenance trend, what data scientists try to do, they try to predict when the machine is going to break. And then you are going to substitute it or repair it or inspect it. I don't know now, it depends on the machinery. You are going to take an action when there are some alarms, sorry, some alarms that tell you that the machine is not working properly anymore. So it has become an exercise of prediction of when the machine is going to break. Now that seems easy, like the churn prediction, but it's not, because since these machineries are very expensive or very critical, nobody allows them to break. If they break, it's a disaster. So there are data sets, training sets, where you have tons of examples of sensory data for the machine working in normal conditions. But then you have very, 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 very few examples, if any, of the machine breaking up because they don't allow them to break
Okay.
up. So at the end, you have to train a model on only normal data to predict both classes, to predict when it's breaking and when it's working. And that's, of course, that's not possible. That's hard. So the thing that the solution, the creative solution there is that you train a model to predict the normal working values. If these values, then you calculate the difference between the real value and the predicted value. If this difference is small, then probably the prediction was correct. Since the model was trained on the normal value, then the machine is working properly. If the difference is very high, then it means that the model wasn't able to predict correctly the real value, and that means that probably since it was trained in normal condition, the machine is not working in normal condition. Now, this is just an alarm. It doesn't tell you that the machine is going to break. Maybe it's the temperature that is not correct. Maybe it's a spike in the energy. I don't know. It could be just, I don't know, the spike of the day. But still, it's an alarm. So you have a bunch of spikes, and of course these spikes they don't say much. So what they sometimes do, they calculate a moving average or a sum of these spikes over a moving window, and then if the number of spikes in this moving window is high enough, then the alarm is fired, something like that. So this is another solution that I've implemented. That's also a few years ago. It's not something that recent. And this was let's say, innovative at the time, relatively complex. So it required a lot of post-processing of the output of the model. Of course, training the model, whatever model you wanted to use. This was a time series analysis problem, but we did the same also with a fraud detection problem. It's the same problem. You want to identify the rare cases of fraud, but you don't have examples because
When
the
there's a
fraud
risk.
patterns constantly change. Yeah.
Yeah.
So, but
So instead you judge where it should be, and when it wavers from that, then that's, like you say, that's an alarm for you to maybe check it out.
right.
Something's not right.
Right.
Okay,
So this was
understood.
another example. Then I've done a lot of things. I've done so. I once, as I said, then I moved a bit more uh, into the leading role. But then once I had a bit of time, and I created a generative AI model to generate lyrics for rap songs. I had a lot of fun there. Yeah, so I downloaded
To
a number of rap songs, the lyrics, and then I trained a small model. It was a long short-term memory, and I was giving. So I trained the model to predict the next character. So I was giving character by the sequence of characters to feed the long short-term memory network, and then the long short-term memory network was supposed to predict the next character. Then I was feeding the predicted character back into the input, and so on and so on, and then the whole lyric was generated. It was fun. Yeah, that was
wow,
actually easy.
was it accurate?
Oh,
Was
I
it
mean, it
accurate?
was, so I did it for the rap songs. For the rap songs, worked okay. I think it's because the grammar and the whole text was not that
Yeah.
complicated. Then I did it also for the Shakespeare tragedies, and that was a much more complicated problem because the text
Okay.
is
Yeah.
a bit more complex. So the biggest problem, of course, was the training time. That's why these large language models, it's a huge exercise in engineering because you have to keep collecting data and then feed this data in these huge models, and then it takes a lot of time, and then of course you have to speed it up. And so at that time with the rep songs, it didn't take much time because the data set was relatively small. It took a few hours with a GPU to train, but for example, for the Shakespeare tragedies, it took much longer. So despite the GPU
Much
was
longer.
a day or so, a bit longer, a few days, yeah, of training. So yeah, I mean, it was the same model actually, just different data and different training times. Yeah.
Sure. It's fascinating with generative AI, I think, with especially in the last year or so, with how fast I think it's become a lot more democratized, so a lot more people are aware of it, maybe that aren't technical, but I think how quickly it's developing as well and what it's capable of is amazing, right? Now I think one topic I wanted to cover is I think there's a large complexities when it comes to actually training of models, right? And when we talk about models, regardless of application or what they're doing, of course there's complexities to building any model. Again, depending on the data sets that you've got as well, but um, and the outcome that you're trying to achieve. But can you give us some insight into what actually happens once a model has been trained, and ultimately what do you then need to do to deploy that model so that it's readily available for whether it's your customers or your application specifically? What's the because I think it's one thing, as I think we touched on at the start, is building this amazing, incredible model, but then how do you actually make that deployable? How do you make it feasible, usable thing?
That's a very, very interesting question. So all these the three use cases that I described before, they were all developed with just with the Knime Analytics platform. So with the open source, free, low code product of Knime. Um, so after, for example, the rap song example, it was fun. It was, I don't know how useful it was, but it was fun. And I wanted to make it available for everybody because everybody could generate his own rap song at that time. So I wanted to generate a web application where people could write their first 150 characters, and then the model would generate the lyrics starting from these 150 characters. So then how do you make it available for everybody? At the end of these whole training exercises, I only had one neural network that was able to predict the next character if you give him a sequence of characters. That's all he could do. So I had to build a web application. In the web application, I had to build, the whole form and user interface, user interaction, and then I had to build some kind of sequence where people could write the first 150 characters, then generate the lyrics or something like that, and then I wanted people to print the lyric that was generated and then go home with their happy lyric. So to do that, this is the deployment phase. It's unbelievable how many people, how many students, especially coming out of the university, know how to train a model 99% percent accuracy, but then they don't know how to deploy it to make it actually to be used. In Knime, then you take your model, you build the application around it, and then you transfer it onto the Knime Business Hub, and that makes it already
Okay.
available as a web application. So you already have, there are some nodes where you can implement visual components of a web page with visual parts of a web page. So you tell, here I want to have my text box where people can write. Here I want to have the text. Here I want, and then you feed um, whatever is the result. Here I want the results, and then you feed the part with the results with the model that you have under that. So this one was relatively easy. And then at the end, I would have a little laptop, and the people would write their own things, their own 150 characters at the beginning, and then they would get their own lyrics to print. So this is relatively easy once you know how you want to deploy it, if it's going to be a web application, a data app, or if you want it to be a REST service, because then of course you have to use different nodes for the deployment workflow. Once you have this deployment workflow, you just move it onto the business hub, and then it becomes automatically the REST service you wanted or the data app you wanted. So this is the part, and this is the part that is missing a lot from the knowledge of the just graduated people. We do challenges often with universities, and I give a presentation, and usually I always ask if I can give the presentation where I explain the difference between the training application and the deployment application. And I don't know, it's like, their eyes open and they discover a complete new world, and finally they understand what the importance of the accuracies. Then it becomes practical, because then, it's useful to have 99% accuracy and 3 more months of training, or is it okay to stop at 96% and we start tomorrow with people using that? So then it all clicks, right? Because the deployment, that we do the whole thing for the deployment, for people to be able to use maybe an imperfect solution, but usable solution. Yeah.
Sure. I think, and it's a really good point. And I think something um, I've seen a lot, especially being in recruitment, of course, is when someone who maybe is coming from academia or purely research projects, there's always that question of when they go into, let's say, a commercial business and a product-focused business, having that mindset of being able to actually push it out to the customer and understand what the customer needs. So you're absolutely right. I think the balance between being able to train a model in a fantastic way with great technical ability, and then also balance that with understanding what the customer will do, how they will use it, the usability, the user experience, depending on your product, of course. It's a
Yeah.
fascinating balance. So certainly sounds like one that you're pushing on anyone and everyone that joins Knime for sure.
Yeah, yeah. At the end, that's the goal, right? Everybody's goal is not the model, is how it's used.
Exactly that. And next, I wanted to the data science field fascinates me from. I mean, you've certainly been in the field for longer than I have, but um, even in the last few years, I think it's remarkable how it's evolved. When we talk about data science and we consider everything within it, so whether it be analysts, data engineering, machine learning, all facets of kind of AI and how data science ties into that. Um, I think there was a previous dynamic where often all of those skill sets that we talk about, the analysis, the data engineering, machine learning, would quite often be rolled into one. Whereas I think these days it's maybe more common that you take a more narrow path and specialize in a particular area, right? Um, when it comes to training models and then deploying them, as we've discussed, what's your perception on what individuals need to specialize in order to do both? Because I think anyone listening to this or watching this, maybe they're graduate, maybe they're not sure what direction they want to go in. What areas of data science, the huge field of data science, would you say are most critical to be excellent at kind of training
Yeah.
and deploying these things?
Yeah, I think we touched a bit on this topic already. So when you have the creation of these models, you have many parts. It used to be that there was the data scientist that does everything, some kind of wizard, and he does everything. It didn't work very well. So now that they
Yeah,
are
don't know how
specializing.
effective it was. Yeah,
Yeah, so now they're specializing. So there is the data scientist, still the original figure. That's the one that takes care of training the algorithm and having a model at the end that has a sufficiently good performance. But then, it's not only the model, as I said before, it's those, the bigger the model, the bigger the exercise in engineering is. So you need, for a big model, you need a lot of data. Otherwise, you're going to overfitting. And so, you need a lot of data. To need a lot of data, you need a lot of data that is clean and collected. To need a lot of data clean and collected, you need a data engineer. So this is how it is. So the success of the model at the end depends on the success of the data engineering pipeline before the model. So the one that prepares the data.
sure.
That's why so recently, close to the data scientist figure, the data engineer figure has emerged. So this figure is the one that is responsible not only for collecting the data, cleaning it up, making it available in the KPIs that people need, or something like that, but is also available for the versioning, because if something has changed in the data, the model will change. So they also need to somehow keep track of all the different versions of the data set, and they need to keep track also of the changes that have been made. If there is another KPI that has been created, or another cleaning procedure that has been introduced. So all these things have to be documented and versioned. So it's a whole new discipline now, the data engineering, and it's necessary because without good data, the model is not, especially in these massive amounts, the model cannot do much. Um, Another kind of figure is so the one that uses the data not to train a model, but more like to present statistics or results. So those are more like the traditional analyst of the data. And then close to this figure, now there is a new figure emerging, which is the machine learning engineers. And those are the ones that they tweak the parameters of the model, and they also supervise the deployment part of the model that has been trained. So there are many different not smaller, but more focused figures, professional figures in the field of data science. It's not like it used to be before, that it was just the data scientist. Yeah.
Of course, and I think I guess part of that evolution as well as the pure scale, right? I think it's if you look back in time, I guess in terms of the how you would be how you would extract certain data, and the size of that data would be comparably much smaller to what we're able to achieve these days, right? So I guess with that, in terms of scalability, I think it certainly makes perfect sense as to why there's those niche skill sets for sure. And I think it's great for anyone listening that maybe is interested in getting into the field, in understanding the importance of understanding that entire chain. And that's not to say to try and be an expert at every stage, but understanding the role that a data engineer plays, understanding the role that an analyst may play, a machine learning engineer, and so on. And I think even then, how then software engineers and software engineering then comes into play at what I would call the kind of front end once a product is actually being deployed to customers. Because I often hear not arguments, but I think disagreements between how data and software kind of merge together and work together. I think sometimes it can be treading on each other's toes in lots of businesses, right? So I think it's a great exercise to kind of understand that full process, so that whatever you
Yeah.
specialize in, you can deploy your own work in the best way that's going to benefit those around you as well, right? So it's an interesting topic, and a very broad one.
Yeah.
Um, Now, another interesting topic is large language models, and I think um, it's certainly a hot topic these days. I think in the last couple of years, with the likes of OpenAI, ChatGPT, and all the kind of famous things that we're hearing about. Um, and of course, LLMs, as they're known, are so paramount to being able to handle huge amounts of data and
Yeah.
build the most powerful solutions. But there's often a discussion around utilizing external large language models that already exist, or investing in building your own in-house. So Talk to me about Nime's approach. Do you have your own large language model? What's your perception on the pros and cons of trying to build your own large language model in-house versus kind of utilizing external?
So I told you already about the experience with training the this generative AI to generate rap song lyrics and the Shakespeare kind of text, right? It was long. I mean, to train that model, it took very, very long. So Knime is not in this business. We are not in the business of collecting data and developing the largest model ever. So we provide the tool to do that if you want to do it. But then you have to collect your own data and you have to create your own model, train your own model, and deploy your own model. You can do that, but we are
Sure.
not in this kind of business. We definitely would use external ones. If somebody, if somebody has already built it, why should we spend, I don't know how long it takes, but it's going to take months before you train a model of this kind of size. So yeah, then our approach is that we definitely would use something that is already available. There is often this question: is the large language model going to take the place of Knime? So because they say they can do everything. So I think the answer is definitely not, because the large language models, they help you. I mean, when you go around and you do the copy and paste of whatever somebody else has already done, a script or even a workflow, a lot of people do stuff, they post it. You find it, you copy and
Yeah.
paste, and you have it on your workflow, on your canvas, almost ready, not ready, but almost ready. That's what the large language model does. You tell him, I would like to have that. He gives you something that is already available on the is already available on the web, and then it's your starting point. It's not perfect. You probably have to know what you are doing to uh, fix it, but it's a starting point. It's your copy and paste. Instead of you doing the search, he does it for you, something like that. So
For
it
sure.
makes your life easier because it's faster, but it doesn't completely solve your problems. It doesn't have your data. It's not the same. So we our I didn't do that, but our CEO did an experiment with the ChatGPT, and he was asking some questions about basic data science algorithms, and then he would get the answer from ChatGPT and re-elaborate the basic answers that ChatGPT would produce and correct them in a more precise and more kind of teaching way. I mean, the result, if you go onto the Knime Press, so that's the book of the month. The result was impressive, not so much for the quality, because the quality is quite basic, but for the time, because at the end it took only a few days to do some basic to assemble a basic knowledge of the machine learning algorithms. You can go onto the Knime Press. It's the first book that you see in the Knime Press page. Yeah, so this is a bit how I think we should use it. We use it for the basic stuff. They do the search for us, so it's great because I don't have to do it. But then, of course, you need to know what you are doing, and you need to build on that to have a
It's
real
kind of like
product.
they're it's Yeah, yeah, exactly. And I
Yeah.
think that can be the misconception. And lots of people that I talk to where maybe they're dealing with stakeholders internally that don't necessarily understand them. I think sometimes there can be a misconception that it's going to solve all of your problems, right? But I think it's a good description that you give around they're extremely powerful in laying those foundations and giving you some very quick kind of turnaround of answers that maybe you never would have got before. But it then needs that kind of specialist or human attention to then refine that and build from that. So I think it's very interesting for me to see how much more powerful they become in the coming years, of course, but also how businesses learn to use them and adapt them in the most efficient way, because they're not needed for everyone. Like you say, it doesn't Nime's business doesn't need an internal large language model because you've got external
Yeah.
options, whereas some companies might say we want to build our own, and that's fine if they have the resources and it makes sense to do that. But yeah, it's an interesting topic for
We
sure.
have actually
And
we have used so we implemented a little feature that in the new version of Nime Analytics platform you can ask the AI agent to build a workflow for you that does the task. It works. I
wow,
mean,
okay.
80%. Then of course you have to
Not
fix
entirely
it.
accurate.
But 80%
Yeah.
it does. At least the beginning is ready, and yeah, you have to fix it. But I mean, it is impressive because I mean, 80% is a lot of work that you don't have to do.
Yeah, absolutely. I think from a time
Mm.
perspective, for sure. And when if your customer's using Knime and does that, um, I assume it's completely on the customer to kind of quality
Of
check
course.
that workflow and then fix it, rather than there's not like an automatic alarm that would
No,
go
of
off
course, of course.
from Nime's end to
They, s-
say, "Hang
yeah,
on a minute,
they still need to
something's
know
not right."
what they are doing. I mean, it's not something that you can just
Sure.
automate completely. I mean, yeah, somebody has to check it. I mean, at least, yeah. And I mean, when we are talking about easy
Now,
stuff, if we talk about complex stuff, then of course then the customer has to do the work.
sure, understood. Now, before we wrap up, I think it's a discussion that we had, and we just mentioned here the book of your CEO, Michael. Now, and the book's interesting because when you and I'll share the link in the comments to the book for our viewers and listeners that they can check it out. But it's 21 analytics insights for data science, written by ChatGPT and Michael, right? So it's a joint collaboration between ChatGPT and Michael himself. So, but give our viewers and our listeners a brief overview of exactly what that book's covering, the benefits that the book's going to give in terms of insight as well. I know, like I say, you've just covered off slightly, but
Yeah, so those are examples, some explanation of how the algorithms work. Now, I don't know, I don't remember all of them, but there are many and how they can be applied. And so, for example, what's a decision tree? How does a decision tree works? So, kind of the basic introduction to machine learning. It's not really a book, a textbook, so it's not something that you study the lesson and then you do the exercise. It's more like, this one works like that, and there is a story around that. And but it's very basic, as I said before. But I mean, it could be an interesting reading for the people who want to get into the machine learning, like as a hobby, without having to study on a textbook. There
sure.
is also the bloopers at the end. There is a section of bloopers at the end that basically shows what ChatGPT couldn't absolutely do. For example, I think at some point he asked to have a decision tree, a painted decision that was Dali, and he asked to have an image of a decision tree, and it was actually a tree with some decisions attached. So there are these kind of things,
Good.
that make sense based on the question, but they don't make sense, in the data science perspective.
In real life.
So there are a bit of
Yeah,
bloopers
for
of
sure.
wrong answers or things that absolutely ChatGPT did not understand. It's interesting to see also the limitation of this kind of
Yeah.
technology. They can do something, but really just something. So the rest is on you. Yeah,
Sure. No, I appreciate that. And I think, like I say, I'll share the link for anyone to read. I'm going to have a brief look. You can just, as a short form to fill out. It's completely free, but it's an interesting
yeah.
topic to and an exercise to run. And I think it's good to show the good and the maybe not so good sides, right? Where it can generate really powerful answers, really accurate answers versus maybe more funny, less accurate answers. But it's just really, and I think the description of the book says it itself, is take it with a grain of salt, because, and I think that's in general how you should definitely be treating them, is make sure that you're double checking, triple checking the information that you're
I,
getting
I
back from them. But
I
um,
think it's interesting exactly to explore how far this technology can go.
Yeah, absolutely. And I think it's only going to become more and more accurate, you would hope, right? But will it ever reach a point where it's 100% accurate? Well, hopefully not, because then I think everybody would be out of a job. But I think it's certainly powerful, like you say, for the more tedious, the more basic tasks of um, uh, in many different industries, not just data science and programming, right? But or building models. But I think to build the foundations of projects that you're doing, time consuming, and I think it gives you the opportunity to free up time for the more interesting things and the more complex tasks that maybe it can't do. So um, let's watch this space, and maybe we'll do another podcast episode in a few years, and things probably would have changed again.
Absolutely, for sure.
But look, as always, a massive thank you to our guest Rosaria. It's been an absolute pleasure to host you and have some great discussion. Thank you to everyone that's tuned in to listen and to watch. Please feel free to like, share, comment, and give us as much exposure as possible. And hopefully you've enjoyed this episode. I will, as promised, in the links to the podcast as well, I'll share the link to the book so that if you are interested in checking out what ChatGPT and the Knime CEO managed to do together, then you absolutely can. And feel free to go and check out Knime's website and even careers page as well if you're interested in exploring the world of low code. But once again, thank you, Rosaria. And for now, goodbye.
Thank you.
Hey guys, thanks for watching this episode. Massively appreciate you listening and checking in with us. If you want to find out more about us and what we're doing, please check us out on social media. What we're trying to do at Enginears is build a community to drive knowledge sharing and experiences. On Twitter, we can be found Enginears.io. It's no underscore. We've also got a website which is enginears.io. These links will all be posted in the description. Any feedback and comments are massively appreciated. We're always looking to improve on where we can. Thanks, guys.